Good evening and welcome to Tinkering with Edkelar. My schedule is still packed with my day job, so again, sorry for the lack of variation here. I'm starting to feel very bad about it. I put up a short recently that showed a pretty damning problem in my cheap, compact and new power supply. It would pulse the output even when turned off. I discovered that quite some time ago and was looking for a linear power supply to replace it, preferably one with multiple outputs that supports series and parallel operation. This current eBay find is a Philips PE1542. It features 3 independent outputs. One has a fixed 5 volts at 3 amp maximum, while the other 2 have the rather typical range of 0 to 32 volts and 0 to 1.4 amps. Each of the outputs has one analog meter that can be switched between voltage and current, and all of the outputs are short circuit safe. The unit arrived in pretty good condition, but I generally don't try to turn it on before refurbishing some things and make sure that the circuits are indeed working. So, let's take it apart first. The case is held together with plastic bezels on the back and front. They need to be pried off so that the cover panels can be removed. These bezels have seen better days for sure, all scuffed up and grimy. The transformer is quite heavy. It takes a lot of iron to get the angry pixies in line. The cover plates are almost good to go, only very minor scratches and a few tiny bends. Overall, the layout is rather clean. We have the power transformer on one side, which feeds into some bridge rectifiers and continues to some really chunky filter capacitors. From there, the power regulator picks up and delivers the regulated voltage to the output sockets, which are connected to the main PCB with the longest standoffs I've ever seen. I thought the knobs here had some screws inside, like the ones I used some time ago, but no, these ones are just clipped on. Doh! An interesting design choice. The side panels might have been intended as heat sinks. They sure have a matching profile and are made from aluminium. But the actual heat sinks of the power transistors are just bolted to them on the inside. Also, the panel meters are directly mounted to the PCB. That also means that the adjustment potentiometers have rather long axles. Can you say foreshadowing? The power transistors also get a rework, complete with fresh thermal paste. Yum! Like usual, I also like to replace the ancient electrolytics, just because. While desoldering the caps from the control PCB, I discovered some repair work. Whoops! Somebody has previously blown away some of the tracks. I also didn't quite like the patchwork, so I did my own instead. When I got the new ones, the bigger filter caps would almost, but not quite, fit into the holding clips. Humph! I really thought they would fit, but they would wobble and probably fall out eventually. So, another good use for OpenSCAD. I like how the clips are designed. Once the cap is in, they pretty much are prevented from falling out without any additional glue or screws. I'm also pretty sure that somebody replaced the wire lugs before. They just don't really look factory to me. Since I needed the new connections for the caps anyhow, I decided to rework the rectifier ones too. I also don't really like the feel of the potentiometers. Some are soft, some are more gummy. The schematic calls for 5 equal value pots, so I don't know why they are different. Maybe another repair job? I did find a complete set of new ones, so yay! Now, getting the potentiometers on the board. Well, I specifically ordered the longest axle ones I could find, and the numbers seemed to add up to the old ones. But the measurement was clearly done from different points. I did try a 3D printed extension, which broke off immediately. What I did find was a flower bed watering pipe that had just the right inner diameter and is also thin enough to not bind up inside the case. Yes, you can insert your favorite Gardena to power adapter joke in here. Since I saw the blown up tracks, I decided to get some spare regulators, just in case. This model uses the nice old metal can version of a 723 regulator. I found new old stock ones even. The power LED in the front is taking up the position of the third channel's voltage regulator. A previous version of this model had the third channel adjustable to 7 volts. And we can still see the space for the components. The power LED is also just tacked to some PCB tracks of the 5 volt output. Does seem a bit like an afterthought, doesn't it? I painted the black side covers and the plastic bezels. Everything else was fine after a good scrub. There's only a minor scratch next to the power switch, but until I can get a color-matched paint, I'll leave that. After assembling pretty much everything except the transformer, I decided to try out the control circuit while I still had access to most of it. I connected my old power supply at the inputs after the rectifier and gave it a go. Well, nothing! It took some serious study of the schematics, which are drawn in a very weird way, to find out that the control circuit is powered from the same transformer tap, but also has its own rectifier diodes and filter caps. So I had to put in AC to power the circuit too. Crisis averted. The transformer has several taps in the primary to allow different mains voltages. When I got it, it was wired for 220 volts. But in the late 1990s, Austria switched over from 220 volts to 240 volts mains voltage, so I opted to change that in here too. That will lower the output voltage and take stress off the regulators. Adjusting all the trimmers inside was a hassle. Like with the Unigore, I didn't have any document that detailed the process. It was mentioned by Philip's part number in the manual I got, but I couldn't find any copy. So, again, I had to deduct the purpose of each pot by adjusting it to meet the spec. There are trimmers for the current and voltage readings on the meters. I did those first. Then there are trimmers to get the voltage and current ranges of the knobs within the specified range. Again, voltage first, current, using a dead short, second. And that's it. I now can use a multi-voltage supply that supports parallel and serial modes. So 2 times 32 volts with 1.4 amps each, or 64 volts with 1.4 amps, or 32 volts with 2.8 amps is all within grasp. More power! And that's it for this episode. I hope you enjoyed it. As for next time, I might need to use a much smaller project as a filler, or even skip my first video in over 2 years. I'm running out of backlog here. But whenever it might be, see you next time! Good evening and welcome to Tinkering with Kelar. My day job, and darn it, now I got 2 more words than the first try. At that rate, I finish at 11 o'clock, November the 21st, 2135.